Welcome back to the channel. Well, we're not in the shop at the moment. We're down at the roundhouse where the Midwest Railway Preservation Society is in the process of restoring, amongst other projects, the 4070 steam locomotive you can see in the background. I've recently become a member and a volunteer in the hopes that I can help out in the machine shop. And today we have a project that involves these big yellow jacks that you can see in the foreground. These are Whiting 50-ton railroad jacks, and they're used to lift up locomotives and other rolling stock when there's a need for maintenance. They're maneuvered around on these large wheels, and then they're lifted up out of the way during jacking operations. On this one here, the maneuvering wheel's axle was bent, so we've got the swing arm removed and we've pressed out the axle. Well, we're back in my shop now, and here's that axle that was pressed out of the swing arm. I'm not sure how well you can see it on the camera, but it's got a pretty drastic bend in it. The wiring at the machine shop is undergoing some expansion. We're adding a big radial drill and a vertical turret lathe and a couple of other big lathes, so they're not available to me at the moment, which is why I've got this back home in my shop. So we're going to take some quick measurements on this and see if we can't find a piece of material that we can use to make a new one. Even though this is going to be a pretty simple project, I still think it's going to be fun to make a part for such a large piece of equipment. And here's that swing arm that's off of that jack. I brought it home so I could take some accurate measurements of the bore here. I wanted to make sure that the part that I do make is correct. The end of this thing is a little bit rusted, and I just wanted to make sure I was getting a good measurement. I also brought home one of the wheels. Now the wheel has a caged bearing in the middle of it, so again I wanted to make sure that the end that fits in here is the right size. Plus I'm going to spend some time cleaning this thing up and maybe giving a little bit of a soak in some evaporust. Well, I have this piece of stock. It's a piece of 4150 that was given to me by Doug over at Metalworks Machine Shop. It's shafting out of a hammer mill, so I think it should be an ideal piece of material to make this new axle. Well, I decided to do all the turning operations with the 4-jaw chuck, mostly because I'm going to turn this end to end, and I want to make sure that both halves of it are concentric. Even though this is a slow-moving wheel, and if it wasn't quite concentric, it would make absolutely no difference whatsoever. But I figure it's always good practice to indicate a piece of material on a 4-jaw chuck. I don't really expect to get this perfect because there was some wear in the shaft, so I certainly expect the end of it here to be out of round with the middle. But if I get it within 20 or 30 thousandths, then I'm fine, because I'm going to be turning off a lot of this material. But when I turn it end to end, that's when I'm going to want to get it spot on. I think we're at the point for this first bit that close enough is close enough. Well, the first thing I want to do is drill the center and then bring in the tailstock with the live center. I want to true up the face, so I've got a DCMT insert in the tool holder. I'll go ahead and face off the end of this as much as I can without hitting the live center, just to give me a good starting point. With the end faced off, I'm going to turn the diameter now down until I can eliminate this surface rust. Take that initial measurement so I can figure out how much material I'm going to need to remove for this end of the part. I guess there was a little more tool pressure on this than I thought. All those grooves as I returned it. Taking a quick measurement here with some calipers, and we can start whittling away this material. The first turning I'm going to do is to turn down the entire length of it to the largest diameter, which is that center boss. Well, unfortunately, my little lathe can't take a whole lot of abuse here, so this material is so hard that I can only take about 10 thousandths off at a time, and that's off the diameter before I end up bogging down the machine. So this is probably going to take a while. I'm going to swap out this CCMT tool for a DCMT insert and see if that might give me at least maybe a little bit better finish. Maybe I can take a steeper cut. Let's see. Well, it's giving a slightly better finish, but boy, it is flinging them little chips right in my face. So I've got this brush here to try to deflect some of it, but it's not really doing all that great of a job. I want to switch back to a CCMT insert. This was giving me a much better chip profile, and they certainly weren't coming up and hitting me in the face. Every now and again it still wants to cut these little snakes where I don't get a good chip break, and I'm not sure exactly why it does well in some places on here and doesn't do on others. If you see something that's going wrong here that I'm doing wrong or could be doing better, please leave me a comment and let me know. I think I'm going to stick with the CCMT for now, because at least they're not hitting me in the face. Well, I've got a different CCMT insert in here now. One of the things that I've been doing is buying inserts with different coatings on them just to see how they are affecting the finish and things like that. This one right here is definitely giving a better finish, but again, it's creating those really stringy chips. I think that's just this material, and I'm just going to have to deal with it. Well, my target dimension here is 2 inches. It's not critical that it be right at 2 inches, but I got this within a half a thousandths. I'm happy with that. We're going to turn down the larger end here up to that boss, and this needs to be about 3 inches long and about 1.5 inches in diameter. Just needs to be about a slip fit into that swing arm. Well, I have 500 thousandths to take off the diameter here, and because I can only do 15 to 20 thousandths at a pass, this is going to take quite a few passes, I think. If I try to take too much more than that, it ends up bogging down the machine and the leather belt just ends up slipping on the cone pulley. So I have to be pretty easy on it, or I'm going to end up just breaking more inserts like I just did. Well, with the fresh insert, dialed this back a little bit. I can get back at it. You can see these chips are just super stringy, and it's going to be a battle of just constantly pulling these strings out while I'm trying to machine this. I've tried different feeds, but I end up with either a terrible finish or it ends up bogging down the machine. So I'm kind of stuck with this. Well, since I'm going to be here for a while, I might as well experiment a little bit here to see if maybe I can do a little bit better with the DMCT insert. Can I get a good finish and maybe a better chip at least? No, this little lathe just doesn't have the juice. I guess I really should quit pushing my luck and just stick with these short depth of cut and just take it slow and steady to win the race. It looks like we got about 190 thousandths yet to go. Oh, we're getting really close, probably within 20 thousandths or so. But I'm going to let this cool off first and then take another measurement. I do want to get really close, as it does need to fit into that swing arm.
12 seconds later.
Well, that's nice and cool to the touch. So we'll use a micrometer here to get a more accurate measurement. Well, it looks like we are within 15 thousandths, 14 to 15 thousandths yet to come off the diameter. I have slowed down the feed, and I have also switched to a TNGG insert to try to get an even better finish. And still have about 5 thousandths to go. Well, this is still cool to the touch, so I should be able to come in here with the micrometer and take a final measurement, and we are maybe a thousandth over that 1.5 inch mark, and that's fine. That will give me maybe just a slight press fit into that swing arm, and I'm good with that. Put the DCMT insert tool holder back in so we can clean up this shoulder and get it to the proper length. Switch over to a chamfering tool to go ahead and break the edge on that boss as well as the end of the shaft. Well, before I flip this part over and start machining the other end, I'm going to put my aluminum covers on these jaws. I don't really think that I'd be marring the finish up too bad. It is 4150, a fairly hard material, but just in the off chance that it does, I'm trying to take a little bit of caution here because this is the first major project that I've been doing for the roundhouse, so I want to at least put my best foot forward. So we'll use the soft jaws just to ensure that I end up with the best finish I can get. I have one of my Federal dial indicators in my indicator stand here to get this piece dialed in. Now this, again, is not critical that it's concentric, but I want to make the best part that I can make. So I'm going to spend the time here to dial this in so that when it's finished, it's concentric. And that looks pretty good. That's within a thousandth of an inch. I could probably get a little bit better, but I think we're good. With the end near the chuck close to within a thousandths, I need to now bump the long end here around until I get that a little bit closer. I'll bump this one more time here, and I think we're within about a thousandths here. So we'll move the indicator now back toward the chuck end. Couple of quick adjustments on this end, and I think we're good to go. We can start finishing this part.
That'll be fine.
And just as before, I'm going to need some tailstock support, so we'll drill the center and bring in the live center on the tailstock. We'll start by turning down this rough end to match the 2-inch diameter of the rest of this half. Well, with a fresh insert in here again, that's what I get for buying cheap inserts. They break a lot easier. We need to turn this end down to 1 1/4 of an inch. And the boss in the middle is going to be a little bit more than 1/4 of an inch thick. Well, that's interesting. I don't think I've ever had chips catch on fire or glow red hot like this. I guess that means I should be using lubricant a little bit more often. Well, they say the definition of insanity is trying the same thing over and over again and expecting a different result. So I might as well put the DCMT insert back in here. I know it's not going to give me a decent chip, but I'm being frustrated a bit too much with the CCMT ones, but at least those ones didn't turn into a big bowl of spaghetti wrapping around the tool holder. And I can still only take about 15 thousandths of an inch off of the diameter, which means my depth to cut is only about 7.5 thousandths. So this is just a very long and time-consuming process. Take a quick measurement here with calipers, and it looks like we have about 100 thousandths to go. These stringy chips are building up, and this gets into a little bit of a dangerous situation here where those things could swing past your arm and do some damage, cut you up pretty bad. So I've got to do a better job of keeping these things clear. Well, that's getting really close, within a few thousandths. It doesn't seem to be cutting a taper, but I think I want to check it with that cage bearing just to see how well that fits. Well, it does slide on there, and even though it does, I could feel the cage expanding a little bit, so I'm concerned that this won't fit into the wheel if I don't take a little bit more off of the shaft. Alright, I'm at 1 inch, 252.5 thousandths. I think that's close enough. We'll put the CCMT tool back in to clean up the center section. It needs to be 277 thousandths wide. And we'll use the chamfer tool here to break that edge. I'm going to measure and mark this in for length. It needs to be 4 inches long. Well, I need to take a little bit more than 1/2 of an inch off of the length of this thing. I thought about taking it out of the chuck, taking it over to the bandsaw, but I think I'd rather just leave it here and use the lathe to shave it down. But I'm going to need to support this end. I'm going to use my steady rest and bring this in, support the end piece, and that will allow me to turn off the end of this to length. We'll use a little whey oil here to keep these bearings good and lubricated. Unfortunately, this camera angle turned out to be terrible. Didn't realize it at the moment, but you're really not going to be able to see much here. I'm just using a DC empty insert to shave off the end of this thing a little bit at a time. Well, I adjusted that downward looking camera, so hopefully we get a good view here of what I'm trying to do. I'm just using the DCMT insert to face off the end of this till I get it to length. And then the last thing we need to do here on the lathe is to chamfer the end. Well, that's it for the turning work that we need to do on the lathe. It looks really good. I'm really happy with how this is turning out so far. The next thing we need to do is drill this hole that's in the end for a cotter pin. Well, we're over at the Bridgeport now, and we'll go ahead and get this clamped up in the vise. I think using the vise jaw should get me close enough to perpendicular and flat. And just to be sure that I don't have any deflection in the part when I drill it, I've got a machinist jack here that I'll bring in and get it snug up underneath it about an inch or so from the end. I've got my edge finder in the chuck here so I can find the end of the part and then also find the center. We'll use the half function on the DRO to find the distance and then move over to 0 to be centered on the part. And then we'll also move down until we are 1/4 of an inch from the end. And as usual, we'll spot it with this 120-degree 1/4 inch spotting drill. Well, the hole size as measured with gauge pins was 195 thousandths. So I think that a number 9 drill will be close enough. This is just for a cotter pin, so it doesn't need to be a precision fit. And we'll use a chamfering bit to give it a nice appearance. Well, with the part now out of the mill, use a deburring tool to put a chamfer softer edge on the opposite side of the drilled hole. Well, that's it. This part is finished. So we just need to take it down to the roundhouse this Saturday and we'll get it installed on that jack. Well, that's it for this video. I hope you enjoyed it. Give it a thumbs up if you did. Subscribe if you're not a subscriber. Thanks for watching, and we'll see you on the next one.